we're going to look at, so before we looked at difference of square trinomials, and now we have perfect square trinomials. So perfect square trinomials is formed from the product of two identical binomials, so p plus q times p plus q, for example. And they can be factored by considering the pattern displayed when squaring binomials. So I could do this a long way, but I'm going to show you what you would end up getting if you were to expand this. So first of all, our p would be squared, giving me p squared. Next, what happens is we multiply my p and my q, which would give me pq, and we double it, which would give me 2pq. And then I would square this term, which would be q squared. So I'm going to write that out on the side here. But p plus q squared is the same thing as saying p plus q, times p plus q. And then if we use our distributive method, I get my p times my p, which is p squared, my p times my q, which is positive pq, and again q times p, which would be positive pq, and then q times q, which would be q squared. If I combine my like terms, I end up with p squared plus pq and pq would be 2pq plus q squared. Exactly what we have here. So sometimes it's just quicker to know what's going to happen if you expand it. So again, with this one here, we would get p squared, p times q, negative q would be negative pq, and we double that, which would be negative 2pq, and negative q squared would be positive q squared. So from the above, what we can see is that the first term in the trinomial is the square of the first term in the binomial. The last term in the trinomial, so q squared, is the square of the second term in the binomial. And then we get a middle term here, right? The middle term in the binomial is double the product of the first and last terms in the binomial. So if I were to multiply p and q, that's the product, which would be pq, but if I double it, which means I multiply it by 2, that is going to be giving me my middle term. All right, so let's look which of the following are perfect square trinomials. Well, let's see. In order to get a perfect square trinomial, it has to be, first of all, the first term is the square of the first, so a squared, so it could have been a, and over here, this is, if I square this, that would be 2 squared. Well, does this represent this? Well, let's see. A squared, check. Now to get the second term, we got to do the first and last multiplied, 2 times a, and then we double it times 2 is 4a, check. So yes, this is a perfect square. This one, however, is not, because 6 is not a perfect square number. This one here, well, the square of this would have been 2x. Square of this would have been 9, so minus 9. Now 2 times 9 is negative 18, times 2 is negative 36, so this is a perfect square. And then this one, this could potentially be y minus 4, but because of this addition sign, this is not a perfect square. Okay, last, before the video gets too long, I'll fill in one of the blanks here. So x squared plus 10, the only thing that this potentially could be would be x plus 10 squared. So 10 times x would be 10x times 2 would be 20x. And I'll do this one here. 25x squared plus 36. Well, 25x squared is 5x plus 36 is 6 squared. And so 5 times 6 is 30 times 2 is 60x. And then last, I'm going to factor just one of these. just to kind of show you how easy it can be to factor these, all you got to do is take the square of the first and the last terms. So square of 49x squared is 7x. Square of 1 is 1, and because there's a negative there, and that's it.